Hello guys and welcome to my video. We're covering exam style questions for A-level and Scottish Higher Maths. So get ready, this is going to be an ugly one. Get your hands dirty. Well, it's not going to be extremely ugly, but it's going to be a little bit messy with the algebra. You have to be very careful that you don't miss a minus sign or whatever. Otherwise you can screw up the answer. Okay, so let's get into this. So we're asked to integrate between the limits 2 and minus 5, this function 10 minus 3x all to the power of minus a half with respect to x dx. Well, looking at that, the function inside this bracket is just a linear function, so we can just use substitution, integration by substitution here, classic case. And that should be pretty easy to integrate once we do that. So I'm going to let u, change a variable, let u equal 10 minus 3x. So that means du is equal to minus 3 dx. And then that means dx is equal to minus 1/3 du. Now this is important, this last bit, dx equals minus 1/3 du, because we basically need to convert this integral in terms of u. So we've got it in terms of x, so we need to rewrite it in terms of u so it's easier to integrate. That's what substitution is all about. And then once we've done that, we can change it back into x later on. Okay, so let's do that. So that's equal to the integral from 2 to minus 5 of u to the minus a half. And then dx, as I say over here, is minus 1/3 du. So I'll take the minus 1/3 outside the integral du. Okay. So integration is the reverse of differentiation. You add 1 to your power, you divide by your new power. So that's u to the half divided by a half. So that's 2u to the half. So and don't forget your minus 1/3. Okay, so that's pretty much it, but it's in terms of u. So we need to make sure, put it back in terms of x. So to put it back in terms of x, we notice that u is equal to 10 minus 3x. So let's plug that in. And the 10 minus 3x is to the half, not the 2, just the 10 minus 3x. The 2 is not to the half. Okay, and don't forget, we're going to evaluate this at the limits 2 and minus... Well, no, the limits here will not be 2 and minus 5 there, because that's in terms of u. The limits will be 2 and minus 5 here, once we have it back in terms of x. Okay, so be very careful with that. You don't need to write the limits at this point, but to evaluate it, I'm going to evaluate it once it's in terms of x at those limits. Okay, so this is what we've got. Now, we can take this 2 outside, so it'll be minus 2/3, and then just so it's a wee bit easier to see that we're taking the 10 minus 3x all to the half. Okay, this 2 doesn't come into it, in case you might be mistakenly, you might raise 2 to the power of a half as well. So you have to be careful there. So it's better just to take all your constants outside. Okay. Right, so let's start evaluating this thing inside, and we can multiply by minus 2/3 at the very end. So if you ignore the minus 2/3 for a minute, let's just focus on this, the bit without the minus 2/3. Okay, let's just focus on that, evaluate that. So that's 10. So we take our first limit of integration, which is 2, plug it in, and then we want to take that all to the half. Now, you must know that anything raised to the half is the same as the square root of that thing. Okay, so x to the half is the root of x. So it's just the square root of 10 minus 3 times 2. Okay. We'll do that in a moment, simplify that in a moment. and then we subtract off the second limit evaluated under this function. So that's minus 10. Now please be very careful with your minus signs in your brackets. This is what I was saying earlier. This is why this question is really ugly, messy. It can get messy and you can make a mistake. You know, there's a lot of minus signs and brackets and things. So 10, so it's minus, and then bracket 10 minus 3x. So what's that? So that's minus 3 times your lower limit, which is minus 5. Okay, be very, very careful there. Okay. And then that whole thing is raised to the half. Okay. And then I'll put square bracket around that because that whole thing is multiplied by minus 2/3, but we'll keep that outside for now. Now we need to compute these two individual parts. So the first one is 10 minus 3 times 2 to the half, so that's 10 minus 6 to the half. The second one is 10 minus 3 times minus 5 is minus 15. So it's minus 15, so it's 10 plus 15. As I say, this is where you can go wrong. And that's to the half. Put our minus 2/3 back outside. Okay, so this is quite simplifying quite nicely now. So 10 minus 6 is 4 to the half. Minus 10 plus 15 is 25 to the half. Okay. Now what's 4 to the half? Well, that's just root 4. And 25 to the half is root 25. And what do you know? These numbers work out really beautifully, don't they? How cool is that? Okay, and then I'll just, as I say, add back in your minus 2/3 multiplier on the left. Right, so we're nearly there. So we've got minus 2/3 times minus 3, so that equals 2. So the answer is 2. How wonderful is that? So it looked pretty gruesome there for a minute. We weren't sure how it was going to end up. So the integral of 10 minus 3x to the minus a half looks pretty, it's not like a simple function like x, you know, you've got your minus 3 and you've got your power minus a half and all of that. Okay, but when you put it through the wash, it comes out to be 2. Okay, so just remember the method that we used. We used substitution, change a variable, we used u. You just need to know what to let u equal to. Pretty straightforward. You've got a linear function there in the bracket, just let u equal that linear function. And then when you differentiate, a constant comes out. Make sure you change your dx into du. Okay, and then make sure you have your constant coming outside the integral sign over here. Don't forget your minus 1/3 and those kind of things. Okay, so generally speaking, whatever that constant is there, whatever that coefficient of x is, okay, you're going to be taking 1 over that, right? And you're going to be multiplying 1 over that by the integrand when you change your variable, when you change it to u. So that's where the minus 1/3 comes from. It's basically 1 over the coefficient of x in that linear term. So that's, a lot of students, what they do is they don't include that. They just integrate the whole thing directly. Yeah. So they end up with that without the minus 1/3. Okay. So obviously if that was plus x, if it was 10 plus x, then that would be correct. If it was 10 plus x, then you wouldn't have any constant term outside. You wouldn't have any minus 1/3. You would technically have 1 over 1, which is just 1, so it doesn't make any difference. But that only works if it's 10 plus x, or something plus x, a constant plus x, or x plus a constant. Okay, and it has to be plus x, obviously. But in general, if it's ax, then it will be 1 over a coming out. Don't forget that, okay? So other than that, it's pretty straightforward after that. It's just evaluating. Now, there's a lot of lines there, but it does look like a lot, but it's not really a lot. Okay, I'm just showing you very, very detailed working out there. Okay, you should be able to evaluate your answer, get your answer faster than that. You should be able to skip a few of those lines. That was only that was a 4-mark question. 4-mark question. Okay. So thanks for watching the video, guys. I'll see you on the next video. Please like, share, and subscribe.